Hello, welcome to my YouTube channel. Welcome to the second episode. Hope you enjoy it. Let's get started. So, I have this little image here, and I will be explaining how the GPU renders so we know how it does, and I can better help you guys understand in this video. So, how does the GPU render? Well, the GPU renders using points. These points are called vertex or vertices if you're talking about many of them, and it connects these vertices forming triangles. These triangles, well, are triangles, and many triangles equal shapes. So, so again, um, how do we actually tell the GPU which points to render? Well, we can do that using a VBO. VBO standing for vertex buffer object, and vertex buffer object is simply just a huge array or memory of data, maybe X, Y, Z, color, UV, normals, etc. All sort, any data, as long as it's a number. Um, so I have this example here. It's a small array. It's not really that big, and it just says X, Y, X, Y, X, Y. X, Y for the first. As you can see, it points to the first vertex 0 1, and then the second xy points to the second vertex, and third points to the third. How do we actually tell the GPU that these two are for the first vertex, these two are for the second, and these three are for the third or fourth, or if there was a fourth, but there isn't? So we can do that using stride, and essentially what stride is telling the GPU how much do we have to jump with our pointer to get to the next same value. In this case, how do we go from this x to this x? Well, we have to jump 4 bytes. We know that. But we have to specify this in a function, in a OpenGL binding function. Right. We also have this thing called a VAO, which essentially is the stride. It's just telling it's not quite like the stride. It's rather telling the GPU which elements are grouped together. So for example, this would be a position, and this would be size 2. This would be a position again, but for the second vertex, and this would be position again, but for the third vertex. With that out of the way, let's get into the code. I have a small example here, float vertices, and I'm not going to be using this, but I did decide to do it so you guys can understand. So I have 0, 1, 0, 1, 0, 1, 1, and this would go from the center of the screen to the right and then to the top right. Why from the center? Is because OpenGL uses an NDC coordinate system, which stands for normalized device coordinates, meaning they range from -1 to 1 and -1 to 1 from the y-axis, and also to the z-axis. Okay, so let's get started with the actual code. We will create a struct. We will call it vertex. And what does a vertex need to have? It needs to have a position, an x and a y. We will add z, but not in this first episode. So let's add a x and a y. Great. So let's actually now create a vertex array of this struct vertex. Vertices is equal to 3. And again, I'm going to do that 0, 0, 1, 0, and 1, 1. Great, we have this data set and ready to go. But how do we actually send it to the GPU? Well, we can send it using a couple OpenGL functions. And keep in mind, these functions have to be after this line of code I added after the first video. So basically here. And make sure you have this added. This is very important, otherwise it's not going to work. It creates a OpenGL context, and a OpenGL context essentially is just telling the OpenGL API what to focus on. But I'm not going to be talking too much about it right now. So let's create a buffer. We can do that by glgen buffers. We can do that by calling this function called glgen buffers. And it takes two parameters. It takes the count, and it also takes the reference to the variable. So I just want to create one buffer, so we put one there and we reference it to this variable I just created, which is a unsigned int. To actually send this data to the GPU, before we can do that, we actually have to bind the buffer. Essentially what that means is OpenGL uses a binding system, which means whatever is the current thing it's using or looking at is it's what's going to use. So if I don't bind this, it might use buffer something else. But as long as I bind it, which means it's going to use this one right now. So if I were to create another one, it's not going to use the other one, it's still going to use this one because I'm binding it. And we have to plop in the type, which in my case is GL array buffer. It's just a huge array, and then we put VBO. Great, we binded it. But how do we actually send the data to the GPU? Well, we can do that by calling GL buffer data, and it takes a couple parameters. Target, which is GL array buffer. For this case, it can take other parameters. Size, which is size of struct vertex times 3 because we have 3 vertices. Data, which is vertices, and usage. Now usage is very important. GL static draw. Usage is very important because essentially it tells the GPU where to put the memory. If it was dynamic draw, so GL dynamic draw, it would essentially mean that I'm going to be changing these vertices a lot, changing the position, the color maybe. But GL static draw just tells the GPU, hey, whoa, I'm not going to be changing these vertices much. And allows the GPU to make some optimizations based on what you selected. Yippee, we did this, but how do we actually tell the GPU the stride, like I mentioned earlier? Well, here's where VAOs come in. VAO, don't forget to add comments. What is a VAO? Well, a VAO, like I mentioned earlier, is just a pointer which tells how far along is each element from the other, so the GPU knows what element to pick. Sounds a bit complicated maybe, but should be easy to understand. So let's create another buffer, VAO, and let's generate it. But vertex arrays. But this time it uses a different function. It uses glgen vertex arrays instead of glgen buffers. But it takes the same parameters. A count and which the pointer to the variable. And again, we have to bind the buffer. But this time we don't have to specify a target, we just specify the reference to the variable. And finally, we can specify the layout. And the layout, essentially what it does is tells the GPU group these together, group these together, group these together, essentially knowing what elements are together. GL enable vertex array. We will set this location to 0, and I will explain this in future episodes, but essentially what it is which layout in the GPU it is, and for now you can just put 0 or, yeah, just put 0. And to tell the information we need, all we need to do is call this function GL vertex attrib pointer. And this function binding takes a lot of parameters. So let me get into it. Index, the first parameter, needs to be the same as the one you put above, so 0. Size, well, it's the size of each element. Not in the sense of every element, just each element. So for the first element, we have 2, 2, which is just the position. So we can put a 2 there. Type, we can put GL float. Normalized, we can put GL false. And if you know anything about math, normalized means it's a unit vector, or from -1 to 1. And stride, this is what I was talking about earlier. We can put here size of vertex. And finally, we can put const void cast 0 for the last parameter. Now this should draw us a triangle. Now you might think we're done, we're ready, we can finally draw a triangle. No, this will not draw a triangle, not quite yet. Last step we actually have to do is we have to, why is it not highlighting? Oh, I messed up. GL vertex. It should be this function. GL vertex at your pointer. Yeah, it is. I'm not quite sure what's going on, but there, it highlighted. So to draw a triangle, all we have to do is GL draw arrays. Put in the type or mode, which in our case is triangles. Put in the first, which is 0, and put in the count, which is 3. Now, big disclaimer, this will not work on every GPU. Not every GPU has a default shader. So if you're not seeing anything and you're 100% sure the code is correct, it's okay. We will get shaders in the following episodes. So save your main file, and run it. And you should be getting a triangle like I am. If you're not, that's perfectly fine, and of course you have to be sure that your code's correct. We will get into shaders next video, and I will explain what they are. But if you are seeing a triangle, congrats, you draw your first triangle. Now before the video ends, just leave some comments if you have to. Maybe do some error checking like I will right now. If GFW, we will just exit 1, and we will put fail to init GFW. Great. So we have a very basic setup right now. It's easy to expand them on, easy to change, but yeah. Hope to see you guys next video. See ya. Bye.